between 13.7 and 15.1. You want to go home. 13.7 to 15.1. Pick it. Well, we didn't do all of these, but we did enough to get the flavor.
A practice
Anything
one
with
from
finding
13.8.
limits.
A practice one. Well,
He wants
I
13.
want
so-
practice with finding limits, just so I can get that out.
Well, then you want to do some more. Do you want more spherical, or you want to go back to Cartesian? You want to do these others, 8, 10, and 18? These are spherical.
Ten's right there.
He has
Ten's
it.
there.
No, she did 10.
Yeah, she's doing,
Quick check, 3 and 4. What about those? Now, these are spherical. Are you tired of spherical? You just want to go back to the earlier section that has triple integrals.
Can you just tell us which one in this section you're putting on the test so we can memorize it?
All of.
You know what's funny about that? You're assuming that you're going to remember the right way of doing it.
Well, I'm going to remember it the way I'm making it.
Yeah, let's go to page 1046.
My book's different.
Let's go to section 14.5, the problems.
how different is it? That's what I'm saying.
No, I have all the same pages as you guys.
Yeah, that's exactly the same.
Yeah.
I never understood why they always make different editions. What changes between a year?
Money in their pocket. Oh, that didn't come out good.
So I was wondering why his was different, but I assumed it was because it was brand new and he got anxious with it.
Okay.
Like I noticed from like the week 1 that your cover was different than mine, or whenever I got.
Yeah, I
the book.
noticed that too. I noticed yours was different. I just thought you just had the American version.
I got what they sent me. I didn't question it or compare it or anything like that.
So the email that you sent, I copied the ISBN out of that, went and pasted it into Amazon.com, and I ordered it.
See, I do that, but first I check what the cover looks like on the actual web
I
sale
don't.
place.
I don't know why that matters. The ISBN
Well,
is for
No,
that-
it matters
that
because
could
this
be
is the
my
IS
fault.
edition.
When you
Does
register
international-
for classes in UMUC, it automatically gives you a scrolling of all the books you need on the right-hand side.
Oh, yeah, but did Amazon send you the ISBN you asked for?
No, yours isn't nice.
Stuart, did they send you the one you asked
You have a
for?
0, I have a 1.
I'm gonna have to check.
The
Email.
ISBNs are different.
It could be my fault.
See, I have 11809 blah blah blah. You have 0470.
Yeah,
But
it
this is
could
the
be my
second time.
fault.
The first time it happened, I was supposed to use like edition 11 of a business book, and they sent me edition 3, and nothing was the same.
Well, yeah, it's like 8
Like-
editions later.
Like absolutely nothing was the same. So then I had to buy another copy of it.
Yeah, I assume 8 editions later is the difference.
Okay, I went down to Cartesian coordinates. I don't really see anything interesting there.
Agreed.
Oh, no. We have to switch the order of integration.
I like chicken.
Okay, 14.5, number 39.
That's not that interesting.
I don't think any of it is.
Number 39A.
39A. Are we doing it all on the board or as a group?
I just wanted to make sure
Your
everybody
choice. How would you
to
prefer?
find the limits.
No, just do it on paper first, see if it's worthy of the board. 39A, they want you to do the Z integration first, the Y integration second, and the X integration third. So this is interchanging the order of integration. For those of you that have a certain textbook, it's on page 1047. And that's probably my fault. They probably sent you the ISBN. I just passed on the one that Maryland's gave me.
I've been reading the book this entire time. It's just been the wrong book.
Yeah, you showed me.
I never trust page numbers anyway.
Oh, he's never gonna trust me anymore. So 39A, we swap out the orders of integration.
So, Z first, Y then second.
Okay. Now, I really recommend, once again, a drawing to indicate what this beast is. Once you have the drawing, then you have to invert the functions. So be sure to label each boundary by the appropriate function, and then invert them as necessary.
Why am I in this weird arctangent page?
Oh, because that's the right integral. Weird. Let's just make it up. Like what you guys put down looks nothing like that.
I don't trust that.
You don't trust the book. It's an integral.
You don't trust the book.
What do you mean?
My book is perfectly fine.
I got the integral out of the back of her book.
I trust my calculator.
Do that integral on your calculator, and it's gonna give you the same thing.
You're gonna go,
Okay, who's got a picture for 39A? What's this thing?
I'm still trying to visualize what the square root of a square is.
39A.
Yeah, give me a picture. Give me an object.
On what page are we on?
1047 in certain books.
And everybody else's but Stewart's.
No one cares about artists' things.
Okay, so what kind of object is this? What's its shape?
Is it a circle?
It's a three-dimensional object. Circle's not a three-dimensional object.
A sphere.
It's a half cylinder.
Yeah, I got a half.
Not a half cylinder.
It's not?
Oh, 0 to 2. Oops, beg pardon. Half cylinder.
It would have to be on top, yeah.
It's a half cylinder, right?
Mhm.
It's a half, so you take a can like this and you slice it down the middle.
Well, I have a quarter cylinder,
You
but.
slice it down the middle, right? It's half of it. Just peel it into two pieces, okay? Straight down the middle.
Well, actually, it's -1.
So,
I'm on the wrong axis here. I'm on the wrong axis.
looks like this, agree?
Yes.
Okay, now you gotta, is it centered on the origin? I think it is centered on the origin, right? So now you need the, you have the picture, so if you get your dimensions, and where is it? Z is 0 to 6, so it's up, and Y is 0 to 2. So it's up.
So it's only a quarter?
No, it goes in the back too.
Oh, it goes to the negative, okay.
Okay, so we have this object, and it's coming out here to 2, it's coming down here to 2, and it's going up there to 6. So now, if you interchange the limits of integration, then this circle here is x squared plus y squared equals 4, true? So you can solve it, you can resolve it for the other integral. You can either solve it for x or solve it for y. So Lynn, what are your new limits of integration if you do z first? So what's the limits on z?
0 to 6.
0 to 6, that's not going to change. All in favor?
Yes.
Okay, now they want to do the y integration second. So what are the limits on y? You have to solve the boundary equation for y. So you found the boundary equation, so solve it for y.
Plus and minus 4 minus x.
4 minus x squared, agree?
Yes.
Good. So that's the y limits. Now what are the limits on x as the last?
X equals plus and minus square root of 4 minus y squared.
No, the x integration is last now.
So is it negative 2 to 2?
It's, no, it is, except I drew it wrong because it is this first quadrant, isn't it?
So it's just gonna
It
do
is this one quadrant, true? It's just in the
Yeah.
first quadrant? All in favor? So 0 to 2, it's the first
Yeah,
quadrant.
okay. So
It's not half a cylinder, it's a fourth of a cylinder.
Who did you listen to?
Well, I said at first it's a fourth cylinder, but you were saying that they have.
I have the wrong book. Like,
Why don't you let Ed J do it? Okay, B.
E.
Let's, by all means, draw this shape. So the y integral goes from 0 to c. So that goes from y equals 0 to y equals z. Well, that's just a straight line, 45 degrees. So y equals z is just some straight 45-degree line. And in 0, the z integral goes from 0 to 3 minus the square root of x. 3 minus the square root of x. So let's just solve this z squared. Z equals 3 minus the square root of x. So when x is 0, the z is 3. So let's draw this in the x, z plane. So when x is 0, z is 3. And when x is 9, z is 0. So apparently it looks like that. And say when x is 4, z is 1. So this is what this thing looks like. It's a square root function. And the other one is 0 to 9 for the z, for the x-axis. 0 to 9. So it just goes out to 9. So y starts at 0 and it goes to z. And zx, z is 3 minus the square root of x. So this looks like that. Goes up to 3. And so this is a cylinder in the y direction. Because there's no y involved. And in this other plane, y equals z, is also a plane, because there's no x involved. So it's a plane that comes forward. Okay. So, and it goes through the origin, and y goes from 0 to z, and x goes from 0 to 9. Okay, so I've got my picture.
Bless you.
It's some sort of weird shape.
It's a wedge of cheese, agreed? It's a wedge of cheese.
Maybe a spherical
No,
wedge.
this goes, this
Looks
slices.
like half of a
No,
canoe,
this slices,
half of a boat.
this slices straight down. So it's a slice. Okay.
Is that top part rounded? That top part is rounded.
This is
though.
rounded.
Yeah.
Okay, so this is the equation z equals 3 minus the square root of x. So this is the plane z equals y. And in the back surface, it's just straight. So how far out does it come here?
0.
Um,
Oh.
Well, z goes up to a maximum of 3, so z equals y, it comes out to 3 also. So now we can draw, we can invert the equations, agreed? We have the drawing, because y clearly goes from 0 to 3, z continues to go from 0 to 3, but now there's a new relation between z and x. You have to solve this equation for x. How do you solve this equation for x? So z minus 3, or 3 minus z equals the square root of x. and you square both sides. And squaring both sides is going to produce 9 minus 6z plus z squared equals x. So that's the new equation for x that you get. So,
I don't know
It
if you
should stay
have
the
to do
same
that.
from zero.
don't have to do that?
No.
No, I should say, we're only switching dy and dx.
They interchange dy and dx?
Yeah, no, dy and dz, dx stays the same.
Well, don't have to do that. Please. Okay, so what about number C? That's not go home problem. Do C and we're out of here.
Oh my gosh, it's so complicated.
So,
48 more hours, just hang in there, dude. This will be our last problem in this course. Number C. Don't get nervous.
All we're doing is changing our integrals, right?
Yeah, but
That's
you'll
what
have to recast one of the functions. You have to invert the functions. Now, they want the z to be performed first, the y second, and the x last.
Yeah, so your z
Okay.
is the 8 minus y, and with the y as the minimum.
Okay, now
So-
first x is going out to the square root of 4 minus y.
That's x. So that goes to the end now.
So what we want to do is, that's x equals square root of 4 minus y. And next comes z equals 8 minus y.
Yeah, but that one's first. It wants,
So now the z integration starts at currently at y. The y integration goes from 0 to 4. I'm not able to do this without a drawing. I can't do it by straight limit swapping. You guys are saying that you can. So you can't. Can anyone do this by straight limit swapping?
well, I thought the dx, dz, dy that it expressed, like in C, I thought all you were doing was moving them around.
No, you have to change the limits. The moving them around is easy. But then you have to find the new limits that will cover the volume. You have to cover the volume in a different order so that your stopping points are different. You just have to be sure you cover the volume. So I can't really do it without a picture. So dx is going the square root of 4 minus y is x. X equals 0 to 4 minus y. What kind of an equation is that? So that's a parabola because
I think the top three term is a half a bluff.
a half a parabolic,
A half a bluff.
half a what?
I'm tired. That's a joke. Half a parabola. A half a bluff.
I'm tired, I'm laughing. So, x equals 0, we don't have any argument with that. X equals the square root of 4 minus y. So that means x squared equals 4 minus y, or it means y equals 4 minus x squared. And what that is an upside down parabola that starts at 4. So we've established a relation between y and x, true? Good. Now let's try to establish connection between other things. The z integral goes from y to 8 minus y. So we have z equals y and z equals 8 minus y. So this inverts to y equals 8 minus z. These are just lines.
It's only half a parabola because y's limits are from 0 to 4.
Yeah, okay, I'll get there. I was just throwing stuff out. Okay, so the relation between y and x is a parabola, and the relation between y and z is a plane, and the relation, well, it's still a plane, it just goes from 0 and stops at 8. So, this is a plane, and it doesn't have any x in it. So we have a parabola, and then we have a plane that cuts the parabola. And the third limit is 0 to 4. And that's going to be y. Y goes from 0 to 4. So that's 0 to 4, so there that is. So y goes from 0 to 4, that's established. So if y goes from 0 to 4, then x goes from 0 to 2. Okay? So x has a limit of 2. Because y has a limit of 0 to 4, so x has a limit of 2, 0 to 2. So we have that kind of a picture. And now let's put it together with this plane. This plane, y equals z, is a 45-degree plane in the yz direction. And it stops y equals minus z plus 8. Z equals y. Z equals y is 45 degrees. Y equals minus z is minus 45 degrees. Goes down 8. So this is looking like that. Y equals minus z plus 8. And z equals y looks like this. Z equals y. So we have these two boundaries as well. And then we have the paraboloid. So there's these two planes. Z equals y and z equals minus y equals minus z plus 8. And these two planes this paraboloid, this parabola, which has no z. What do you mean for a parabola to have no z? That means it's a trowel. It's a cannon, because it has no z. So that means it has 3 dimensions. It's like that. It's a tunnel. Okay? So it's a tunnel in the z direction. And the limits in the z direction are the plane z equals y, which is 45 degrees. It's going to come down like that. Z equals y. So that's going to cut that. And then the other plane is going to be minus z. Okay, getting close now. Y equals minus z plus 8.
It's like not Pictionary. This is for real.
No, I actually think I know what it.
Oh.
Yeah, I think I have a picture of it.
I'm not seeing this picture.
Nope.
I drew it.
You drew it?
I drew it. So here's the y axis, here's the z. It's 4, 0, this point right here. I guess there's that for z. And so this is 2.
Yeah, let's do it again.
So that's the tunnel created by,
The parabola, yes.
and then
Okay.
there's that and that.
Y equals z. Yes, that's what I was getting at. Yes, I was going there. Right. And, yeah. That's it. Absolutely right. And
Wow.
this and this Now, is this plane, is the back plane is also a wall, right?
Yes.
Okay, good. So, yeah, that's it. And the other plane, then comes up like this.
Clipping art really paid off for me.
Okay, so now, going from the drawing, we can get our new limits.
Where did that canopy come from?
Cabela's.
Okay, now we can get our new limits. What's the first one they want us to do first?
DZ.
DZ?
Yes.
Okay, so from your drawing, Z is from 0 to 8?
Yes.
And the next one they want us to do is?
DY.
DY.
And,
Actually, but DZ is it changes because so it goes from Y to 8 minus Y.
Minus Y, that.
yes, goes from Y to 8 minus. Or 8 plus or minus or plus?
I
Eight
have
minus Y.
8 minus Y.
Well, the original equation was Z equals 8 minus Y. Okay, I see what you're saying. Okay, so now what one they want you to do next is the Y?
Yes.
Well, that's easy, because all you have to do is convert X and Y. So Y goes from where?
0 to 4.
0 to 4.
No,
0 to 8.
no, 0 to 3.
0 to 4.
4 minus
You
X
had
squared.
4 as the top of the parabola.
Yeah.
Okay. 0 to 4. Now tell me within what X goes.
0 to 2.
Well, this can't be right because we haven't used the relationship yet that,
So it has to be,
that X
Z in
equals
the
the
middle.
square root of 4 minus Y. We haven't used the
yes, you're right.
relationship that X equals the square root of 4 minus Y.
yeah.
So we have to change
minus
this Y
X
relationship to X squared equals 4 minus Y. So Y equals 4 minus X squared up here. Okay, divided by it. Done. Lynn knew that an hour ago.
I'll accept your update.
Okay, next item, test. See you then. 4 o'clock.
4 o'clock is when it's starting?
Well, it doesn't have to. Come when you want to.
I know,
No
but
later
4
than
o'clock,
6:15.
4 o'clock
I'll be
is the
here at 4,
earliest.
yes.
Okay, that's what I meant.
Enjoy.
And you'll be here till 4 in the morning, right, the next day?
Sunday. This is it.
I've had a horrible headache all day,
Really?
and I'm glad to say that calculus hasn't made it worse.
How in the world have you ever
My
been
headache
able to
just
do
started
anything
now.
with horrible headache?
My head was full of happy thoughts, now it's just hurting.
What incited these happy thoughts?
AJ